Alright, this is just gonna be the walkthrough for the Newton's first law of motion worksheet. So, and you know that, well, the question is asking which object has the greatest inertia? Well, we know that mass is proportional to inertia. There's a linear relationship here. There's a linear relationship, or we can call it direct. We can call it a direct relationship. Now, speed doesn't matter. Speed doesn't matter. If you have, let's say, a giant tall building, let's give it windows, windows, and you try to move this insanely abnormally tall building, it's going to be very difficult. It's going to be very difficult. Let's say you want to move it this way. It's going to be very difficult. Why? Because it has a lot of mass. If you ever wanted to move like a tiny box, a tiny wooden box, it's wooden, and that's going to be wooden. If you're trying to move a tiny wooden box, it's much easier, right? Compared to trying to move an entire building. And because it has lower mass, higher mass, and so this is going to be higher inertia. It's going to get it's harder to move it because it has a lot of mass. So it has lower inertia. It's only it only depends on inertia. Only depends on mass. Inertia only depends on mass. Velocity doesn't matter. How fast you're going does not matter at all. So the speed doesn't matter. Speed slash velocity doesn't matter. Alright? So if only this is true and this is true right here, well, which object has the greatest inertia? And that number one. And you'll see that D has a mass of 8, which is the highest. So the answer is D. D. Right, D. Now, number two, a 15 kilogram cart is at rest on a horizontal surface. A 5 kilogram box is placed in the cart. Compared to the mass and inertia of the cart box system has what? So you're comparing something to a cart, and the cart by itself, cart by itself. So a cart by itself, and then you have a cart box system. So not only are you taking the cart, you're taking the box too. You're adding both of them. So this is the cart box system. Well, the cart box system has more inertia. Well, not only that, more mass. Again, 20 is greater than 15. Not only does it has more mass, well, it has more inertia too. We know it's proportional. We know that if we have more mass, we have more inertia. This is something that we can assume to be true. All right? So the answer is A. Answer is A. Number three, which object has the greatest inertia? Again, I told you speed and velocity doesn't matter. If speed and velocity don't matter, the only thing that matters is your mass. Alright, so which one has the highest mass? Well, A. Choice A has the highest mass. Now, 4 is a bit of something to do with equilibrium. I'm not, I'll talk about it in another video, but for now you can just skip number 4. Just know that the answer for number 4 is D. Alright, the answer for number 4 is D. Well, I'll explain it in another video, in the equilibrium video, but you don't need to know it for now. You don't need to know how to solve it. So number 5, compared to 8 kilograms of feathers, 6 kilograms of lead has what? Well, 8 is greater than 6. 8 is greater than 6. That's not how you write greater. 8 greater 6. So this is more mass. Alright, so the feathers, the kg of feathers, there's more mass here. So it's going to be either C or D, but we also know more mass, more inertia. More mass, more inertia. And so it's going to be D. D. 6. Definition of force is push or pull. It's the definition. 7. Which object has the greatest inertia? Again, more mass, more inertia. Speed doesn't matter. D has the most inertia. Alright.